are going to be talking about mixtures and solutions. Has anybody ever heard of a mixture or a solution before? A couple of you, actually most of you. Okay, can you kind of tell me what the difference between the two is, where you've heard of it before? Gonzali?
I've heard it from my big fat notebook thing.
Okay, the science notebook that you read sometimes?
Yeah.
Okay, yeah, so Zolly has this book and it's got all of this information about science and how to pass science in middle school, right?
Yeah.
Okay, so she's read it in that book. Today you will be doing the lab. That's why there's all of the items around the room. You're gonna be put into groups, and the lab obviously is on mixtures and solutions. So in your lab, you're going to be combining some substances together and then trying to separate them, which after watching the video, you'll see separating is a big difference between a mixture and a solution. So we'll watch this quick video and then we can jump right into the lab. Do we have any questions so far? Nope.
Hey, birthday girl.
Sam, what's up? I'm just setting up some munchies for the party.
Sweet. I brought the cake Mia and I made.
Oh, this is awesome. You guys rock.
What you got here?
Just a few mixtures of some tasty treats. Have some.
Ah, mixtures, my favorite.
How can mixtures be your favorite? That doesn't make any sense.
I don't know. I like mixing things. It doesn't always have to make sense. I'm an artist.
Sam, do you even know what it means to be a mixture?
Not really. But I've been happy to have you enlighten me while I snack on these.
I'm sure. Mixtures are physical combinations of two or more substances that retain their properties when you mix them together. Unlike a compound, which is chemically combined, a mixture is a physical combination.
Okay. So what's a mixture? Sophie?
Two or more things being combined.
Together. And are they physically combined or are they chemically combined? Andy?
Physically.
Physically, good.
That means it can be easily separated.
Yeah, I can see the different parts mixed together here. It does look easy to separate.
Well, there are two different types of mixtures. Ones you can see the different parts of, and ones you can't. This is an example of a heterogeneous mixture, because you can see the substances that have been mixed together.
Peanuts, pretzels, and chocolate chips.
We can easily pick apart the substances and make separate piles.
So, heterogeneous mixtures you can see the parts of.
Okay, so make a mental note of that. A heterogeneous mixture, you can see them. You can see the parts. Heterogeneous, you can see the parts.
A seed.
Now, just so you know, a mixture doesn't have to be just a solid. It can be a liquid or a gas, too. This lemonade is a mixture known as a solution. A solution's parts are blended evenly.
Is that the kind of mixture where you can't see the parts?
Yeah, a solution like lemonade is homogeneous. You can't see the sugar, lemon juice, and water that have been mixed together to make it.
Are solutions always liquid?
Nope, a solution can be a solid, liquid, or gas. It just has to have a solute and a solvent.
Okay, so what's the difference between a mixture and a solution? Vera?
A mixture is like you can physically see it and easily take it out. A chemical.
No, a solution.
Chemically mixed together. You can't see like the ingredients. You can't put it apart.
Okay, good. And now the video is going to continue on and talk to you more about solutions and the parts that are in a solution.
The solute is the substance that is dissolved in the solvent. In a lemonade, sugar is the solute because it is dissolved in the solvent, water.
Well, I'm glad this solution is a liquid. It sure is the solution to my thirst.
Okay. Well, come on, make the birthday girl proud. Show me what you got.
A mixture, like this snack mix, is a physical combination of two or more substances. The substances in the mixture don't change when they're mixed, and they can be separated. We can see the different parts of the snack mix, so it's a heterogeneous mixture. A mixture isn't always a solid. It can be a gas or a liquid, like the lemonade. The lemonade is a solution, and solutions are homogeneous. You can't see their parts. Ta-da! How was that, birthday girl?
Happy birthday to me.
That's right. Now, let's get this party started.
Okay, so I want to go back to where it talked about solutions really fast. So in a solution, the solutes are what is being dissolved, and then the solvent is what, Amber?
The solvent is like what this solute is dissolved by.
Dissolved by. So as they mentioned in lemonade, the solute is what? Maddie? Not water. Alex? The sugar. And then what's the solvent, Maddie?
Water.
The water. So solute is what's being dissolved, and solvent is what is being dissolved in. And this is just kind of an introduction to it, so maybe later or tomorrow we're going to go over a PowerPoint on this, and then you'll be able to write down all the definitions that you'll need for it too. But, okay, so before we begin today, I'm going to go over your lab sheet. So as you can see, you'll be put into groups mainly of 3, but there's going to be 2 groups that have 4. This is your lab sheet, and there are 6 stations around the room. Station 1 starting at the back table, and then it goes all the way around, and the last station is at Zach's desk. So what you're going to do is, with your groups, you are going to go over to each station, and at the station, you're going to write what you're mixing together. So for example, Damien, at your desk, what would you write? What's being mixed together? With the water, yeah. Hawaiian Punch and water. Those are your substances. And then you are going to, there's also directions posted at your stations too. But what you're going to do is, you're going to mix the cup of water with the cup of salt, sand, oil, whatever you have at your station. And then you're going to stir the 2 items together with your spoon. And while you're stirring the 2 items with your spoon, I want you to examine the substance that you're making. And before you do anything, talk with your group. What do you think this is going to be? Is this going to be a mixture, or is this going to be a solution? And just talk about it, throw some ideas around. Then, if you think that it's a mixture, discuss how you could separate it. I've given you some tools at your station. I've given you rubber bands, cups, spoons, and coffee filters. And with your group members, if you think it's a mixture, you're going to discuss how you're going to use those items to separate it. Or if you think it's a solution, talk about what you think is the solvent and what you think is the what you think is the solute and what you think is the solvent. And then you're going to test that using those items. So again, from the video, in a solution, what is the solute? Joe?
Sugar.
Okay, the sugar, but what? Give me like the definition, because there's not sugar here.
Dissolve.
It's what's dissolved, yep, and then what's the solvent?
Oh, water.
Like water, whatever liquid you're putting in it, whatever it's being dissolved into. And then after you are done mixing and trying to separate, you're going to go back to your lab sheet and write if you and your group members decided if it's a mixture or a solution. And then in the last section, you are going to put, it says, if this was a mixture, explain how you separated the substances. And if this was a solution, tell me what is the solute and what is the solvent. Any questions? No? None? Okay. So to put you in groups, I'm just gonna go around and I'm gonna count you off 1 through 6. So like I said, there'll be 1 group, 2 groups that have 4, and the rest of you will have 3. Okay? So Olivia, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. Raiden 5. Callie 6, 1, 2. So all of the ones stand up and go to station 1, and I'm gonna come around to each station and I'll give you your lab sheets. You're going, station 1 is over at the back table by the lunch cart.
Oh, we're fine.
You have 5?
Yeah.
How did I do that?
It's fine.
Okay, whatever. And then all of the people in station 2 stand up and go to station 2, which is right next to the girls. And at each station, you will have 6 minutes to mix together the substances, follow the directions, and talk about it. Okay, 3s can go to 3, which is back here by Miss Imshirt. Here's your lab sheet. Group 4s can go to station 4, which is at Raiden's desk.
I think they both have 5, so you can pull one from the boys if you want.
Isaac, come over here, please. So you're gonna be in this group now.
Marcus, can we dismiss, please?
Yeah, follow the directions at your station. So you're gonna mix the 2 substances together. Okay, 5s can go to Damien's desk, and then 6 can go to Zach's desk. All of them.
Do we do just one
In 1 cup of water. Yes. And then Amber, will you come to this room? Sorry. Yes. Okay, give me 5 real fast. Give me 5. Okay, so when you're at your stations, I know there's 6 cups of water and 6 cups of sand or whatever. You and your group are only going to be using 1 cup of water and 1 cup of sand, or salt, or oil, whichever. The reason why there's 6 at each station is because there's going to be 6 groups moving around.
Oscar, I don't know.
I'm ready to actually.
There are the 2 items. David, David, I'm
You're welcome.
I made so big. We're having this our instructions on I like just they said
You guys also have coffee filters and rubber bands too. When I was at home doing this, I used the rubber band to hold the coffee filter over the cup, because otherwise mine fell in. But it's up to you, whatever way you want to try and separate them. if you're trying to separate and one way isn't working, maybe ask your group members for a different way that you think you could try and separate.
Fish 3 was 1. So,
Use your extra cups if you need to. Rubber bands too. Yes. Yes. So what substances did you mix together? Yep. Done. Try and separate it.
is there a way?
Is there a way?
No.
Okay. Give me 5. Is everyone ready to move on to the next station?
Yes. Almost.
Not yet.
So first,
Okay, I want all of the groups to now switch. So I want Brayden's group to come to where Zach's desk is, and I want Amber's group to move over here. So everyone should be rotating
Okay.
The powder?
Yeah. Did you try separating it? How do you know it won't work? But you've got all this other stuff.
And if you try to put that here, it'll
You can take those out and use those cups too.
wait. This goldfish. Are we allowed to use these?
Yeah, you're allowed to use all the stuff at your station.
Okay.
Yeah, try with the rubber band. That's fine. Yeah. Okay. Pour it slowly.
Look, see, I separated. This is a lot more oil. Just pour it slowly. Okay, so
Watch it. It will rest.
I know.
How's it going? Have you tried separating it?
We tried using one of these things to pull it.
You actually?
No, David emptied it out. I put it to the bottom. Started to clear it out. That looks like glue. Touch it.
Probably like one more rotation.
And then, yep, you just support each other. And then I push it down a little so you can actually see the cat in there. That was your pencil. Okay, now try. But look for the most part. Is it a solution or is it a mixture?
definitely, because it's like if you start up and
Caitlin and Anzali.
You can see both of them.
Okay. So I want everyone finish up filling out your lab sheets and then switch to the next station.
First floor, substances.
Mm-hmm.
that's way too much.
just a little bit, so then it'll come up a little. Yeah, and it'll like overflow.
I separated it. Oh, yes, let's fill up another cup with it. Oh!
Keep mixing it in your cup.
Here, I know how to do this.
And then yeah, just pour it, but wait a minute so it doesn't go over.
Very slowly. Yeah. Otherwise, whoever does it.
The next one I'm mixing.
Wait, how do you get it? Pour it over.
The drink.
Okay, look it down. Alright, here we go.
Okay, so
So from just looking at the cup of oil and water, what are you predicting it'll be? A solution. Mixture, why is that?
because it's not mixing, like it showed when you poured it in, it didn't mix it, it was just in the
Yeah, see how the oil and the water are completely separate from each other?
overflow this.
Careful. So how did we do it? We discussed because
Not all of it. Not all of it.
That's cool. Oh, that's a mixture. Put it right there.
Just set it aside.
Yeah, put it right there. Okay, so it's
Yeah, it's working.
You guys having fun?
Yes.
I like that. When you try it like this, yeah. We tried with the picture. That's how we know. They just. When you use that, it's easy. Yes, what did you?
Yeah, if you push it down a little bit.
Mixture. What did you use?
Yep, and then you can just go right over my hands. Then if you push it down a little bit, there leaves room for all of this water to go in. Okay. So what did you guys get?
We got milky.
Yeah. Did you guys use a coffee filter at all?
Yes, we
What we do is
So when, I don't know if you guys felt, but when you use the coffee filter, even though obviously the coffee filter is white, you can't see the baking soda sitting on top of it. So when I was using it at home, I felt my coffee filter and I could feel the baking soda on it. Okay, give me 5. Okay, we're running out of time a little bit, so I want everybody to return back to their seat. If there's stuff on your desk, just stay away from it. When you guys are at specials, I'll clean it up.
Kofi.
Coffee filters were really useful, like really useful.
Yep, they were helpful in separating, right?
Yeah.
What was something that you were able to look at immediately before and you were like, that's it, like this is 100% a mixture, this is 100% a solution?
The salt.
The salt, okay. What did you and your group decide that it was?
We decided that it was a solution.
Okay, did anybody have anything different? Sophie,
Oh wait,
for the salt. Caitlin, did your group do salt? Okay, did you agree with that it's a salt? Okay.
Oh,
Yes, Sophie.
for oil, it was a mixture.
Okay.
Because you could separate the oil from the water.
Mm-hmm. Dave?
Just the water, I would know the mixture.
Mm-hmm. What about the marbles in the water? Who got to do the marbles in the water? Xavier?
It was a mixture because you could see both of the ingredients and you could separate them.
Mm-hmm. You could easily separate them. Did you even have to use the coffee filter to separate the marbles from the water? No. You could use the spoon if you really wanted. You could just stick right in there, pick your hands out, like use them to pick out your hand. So what is the main difference between a mixture and a solution? Andy?
Make sure you can see the different substances and you can easily get them out on the solution. You can't see because they're already mixed up and that's the difference.
Okay. And then, Sophie, what were you going to say? Anything to
That
add?
you can go back for a mixture and solution, you cannot go back.
Mm-hmm. Do you think if I had given you guys different ingredients, or what if I gave you hot water instead of room temperature water, do you think that would have had any impact on how the substances either mixed together or separated together? Vera?
Maybe because like a different temperature. Like if you use a coffee filter, you could have it maybe like not melt it and suck through easier.
Mm-hmm. What about who got to do baking soda and water? Who thought it was a solution? And who thought it was a mixture? Okay. Charlotte, why did your group decide that it was a mixture?
Because when like it didn't fully dissolve and like we put the coffee filter over it and the water like it just formed like a
Mm-hmm. So Charlotte's group used a coffee filter. This is all baking soda. And they did the same thing that a couple other groups did, and they, took the coffee filter, poured the water out. So just from looking at this, do you think baking soda was a mixture or solution?
mixture.
A mixture. What if we had used boiling hot water and sat there and mixed this for a while? What do you think would have happened?
Solution.
It would have become a solution. So temperature plays a big role in if something can become a mixture or a solution. Okay, so it's almost time to go to specials. I want everyone to, you can put these lab sheets away. We might continue this just so you guys have a chance to get to all stations after specials. I'll ask my sister. We'll see. Good. Yeah, you